Saskatchewan currently lacks the infrastructure to harness the abundant wind power across the prairies. To do this, the shipping industry has created the ME229 design competition. Our group, the Gliders, has decided to take on this challenge. The problem statement we came up with to tackle this challenge was to develop a land-based wind-powered cargo delivery system which can make fast and accurate deliveries with low emissions. During our problem definition, we focused on optimizing objectives such as accuracy, load, speed, and carbon emissions. We were constrained by size, cost of materials, and the time limit for the trial.
Throughout our ideation process, we brainstormed 4 main designs which could be viable options for the shipping industry. The first design we came up with was the classic sail car design, which harnessed the wind from the leaf blower to propel the car forward. The second design we came up with was a paddle design which incorporated a vertical paddle which turned the axle. The third design we had was a ramp cart design with a sticky front bumper. This design was planned to travel as quickly as possible to the end wall and stick to it. Our fourth design consisted of a basic cart on a ramp that is held there by wheel chocks. To evaluate our designs, we came up with a weighted decision matrix based on our initial objectives.
Our final selected design was a ramp car system with a release mechanism, where the release height could be adjusted using a string connected to the ramp and the cart. This allowed for the cart's rollout distance to be adjusted and the accuracy to be fine-tuned. To fabricate the design, we organized into 2 groups who would primarily focus on one component. Saul and Liam focused on the ramp, whereas Carson and myself focused on the cart. This ensured that each part of the design would progress smoothly, and each member's expertise was utilized to the fullest extent. During testing, we found that the wheels and release mechanism needed optimization. For the release mechanism, we designed a completely new frame system to release the cart more consistently. For the wheels, however, we iterated 4 times to optimize the rolling efficiency and weight carrying capacity.
After we completed iteration, we came up with our final design. Our final design consisted of 2 wooden dowels in the middle that hold the weights, an L bracket on the exterior, which is connected to the fishing line on the ramp, a rotating hinge that releases the fishing line from the L bracket, and an axle housing on the bottom that contains our wheels. On competition day, our design performed as expected. We were able to carry the maximum weight of 8.1 kilograms and finish with a time of 6.19 seconds. Unfortunately, we ended up in the overrun zone, leading to a point deduction, but we still managed to finish in 6th place with a score of 0.654 kilograms per second. As a group, we learned a lot throughout this design process, and we are very excited to see where future design endeavors might lead us.